I know I'm not going to see a bunch of you tomorrow, so you could work on the things if you had some free time or whatever. You will have all day during class on Thursday, but it would be smart to just try them and see which ones you need help with on Thursday. So me or your friend or whoever could help your friend. That would be the smart thing to do if there is a quiz on Friday. That would be the smart thing to do. Okay, let's see. There was something else I was going to say. Word's not coming. Oh, yes. So some people have the ACT tomorrow. If you are one of my freshmen, I need you to have out a pencil and to write this down now. If you are a freshman, I need you to write somewhere in your life 227. Elena, I don't see you writing. 227. 227. We will not be in my room tomorrow. They are testing on the 100 hallway. We will be in room 227. They are not going to let you on this hallway. They're not going to let you on this hallway.
Freshmen have to be here like on regular time?
Yeah.
Why?
Remember last year? Because y'all not
Must be nice. Okay.
So 227. Okay. I love you dearly.
She doesn't want to talk.
Yep, I can't. I really can't. That's like 3 minutes of me saying that on YouTube. Awesome. Okay. Let me get all my words out all I can. I need two things. I need to go over the bell ringer, and we need to do the notes. We can do notes pretty quickly. They're actually a little easier today than they were yesterday. Thank you, Danny. Okay, on the second bell ringer question. Okay. On the next one, it says GCF, which is the greatest common factor. So we want the largest thing that will divide into 42, 26, and 126 and 210. Obviously, 2 goes in, but it's not the biggest. Surely there's something bigger. 42 actually goes into all of them. Now, if I had guessed, I would have never guessed 42. I would have eliminated the largest and the smallest, but it actually is 42. Because it goes into 42 one time, it goes into 126, I think 3, and it goes into 210, 5. Okay, on the notes, there are two formulas we're going to have to learn today. One is for trapezoids. The other is for rhomboids and chiasms. The one for a trapezoid we've actually seen before. The H is for the height, the B is for base 1, the other B is for base 2. Again, just like yesterday, you can find the height if you can find that 90-degree angle. It's the one cutting across the shape. It's in between the two bases. Now, the first two today are actually as easy as it gets because they're plug and chug. We're just going to plug in some numbers and get an answer straight out. I need a value to plug in for the height. What should I plug in for the height? Isaac. Okay. Yes, dear. One for the height and one for the base 1, base 2. Yes, we're going to. What are the two bases? 3 and 2.5. Okay, perfect. Now, if you need to, you could type that whole line in your calculator, but we're pretty smart. 1/2 times 1 is just 1/2. 3 plus 2.5 is 5.5. So I just need to know what is 5.5 divided by 2. Okay, 2.75, and what are my units? Is it squared or not? Anytime for area, it should be squared. Okay, I'm moving on quickly because that one's rather easy and the next one is as well. So it's 1/2. I need to know the height. I need to know my two bases. If Grant's trying to get some pity points out of me, he'll at least put the formula on the test, even if he doesn't plug in the right people into the right spots. Showing me he knows the formula gets him most of his points. Okay, what is the height? What is one of the bases? And the other base? I understand Hazel can do math in his head. It's okay if he went straight to the 55. I would definitely understand. So I need to know 1/2 of 11 times 55. I think that's 206. I don't know. I wanted to say things. I don't know. I think that's 1/2 of 605. I need a final number. Thank you. Okay. So far, the trapezoids, even though you have to remember the formula, that's about as hard as it gets because everything else has been straight, just plugging in and getting out an answer. The reason it's been that way is notice they haven't drawn it to look like a triangle. We can already tell 3 and 4 are going to be a little harder because we can see that triangle hiding inside the trapezoid. I'm going to show you 2 different ways to do 3, and then we'll vote to see which way we do 4. Okay, on number 3, again, I need that formula. Area is 1/2. I need to know my height. I need to know my two bases. My height is 4. One of the bases, because I assume that's the right angle, so that might need a little of me assuming. One of the bases is 9, but I don't know this top base. I'm going to have to figure it out. It looks like a square, but how do we know for sure it is? There's nothing on there telling us that. So instead, we're going to turn it into a triangle problem. We have a right triangle. We know the hypotenuse is 5. We know one of the sides is 4. We need to know the third side. 3, because we know our triple 3, 4, 5. If you still don't know your triples, you could use the Pythagorean theorem, but surely you know 3, 4, 5. Okay, so I know this yellow piece at the bottom is 3. The whole length of the base is 9. So how long is just the pink part of the base then? 6. So that means the top is also 6. So my missing base is 6. Are there any questions about how I got that 6? Well, 1/2 of 4 is 2. 9 plus 6 is 15. 2 times 15 is 30. So my answer is 30 feet squared. Okay, but I said there was another way to do this problem. What 2 shapes do you see inside this trapezoid? We see a triangle. And what else do we see? A rectangle. It's not a square, it's a rectangle. So I've got a rectangle, I've got a triangle. One way to actually find the area of this shape, instead of using the trapezoid formula, is to add the area of that yellow triangle to the area of that pink rectangle. So for the rectangle, we know it's 4 times 6, because it's base times height. So for the rectangle, it's 24 feet squared. Now for the triangle, we know the formula is 1/2 base times height, but we know that base is 3. The base of the triangle is 3. And we know the height of the triangle is 4. So it's 1/2 of 12, which is just 6. What do you get when you add 6 plus 24? You do get 30. So again, I can get 30 feet squared by using my trapezoid formula, or I can get 30 feet squared by adding the area of the rectangle to the area of the triangle. Now this, where I did the 2 separate ones, is really smart because they might give you a weird shape we don't know a formula for. But I admit, it does take a little extra time. So now you get to vote. Would you rather use the trapezoid formula? Who would rather use the trapezoid formula? Raise your hand. Raise your hand if you would rather do like a composition where we add the 2 colors together. That's what I thought. Okay. So here we go on our last one. We're not going to use, even though I do secretly see it looks like a rectangle living inside a triangle, or a rectangle and a triangle living inside a trapezoid. We're not going to use that. Instead, we're going to use our trapezoid formula. So 1/2 the height. I need to know base 1 plus base 2. What is the height of this trapezoid? The height is 8. I know one of the bases. Which base do I know? 14. I'm very tempted to plug in the 10 for the other base. Is that a good idea? No, that is not the length of the other base. We're missing that. So do we just give up?
No. Yes.
And then we don't make a good grade, do we? So we need to figure out something to do instead. We're going to solve for this triangle over here on the side. We see that the hypotenuse is 10. We know this side is 8. We need to know the bottom. Now it is a triple, and if you can come up with it before I can finish the Pythagorean theorem, I'll be impressed. Okay, so what number should I put on the bottom? Yes. Okay, so if you know your triples, 8 divided by 2 is 4. 10 divided by 2 is 5. 6 divided by 2 is 3. It is a 3, 4, 5. So you know it instantly. Or, if those triples don't come to you easily, again, you can always use the Pythagorean theorem and solve for x. Okay, so I got 6. Do I plug in 6 for our base then?
No.
No, that just tells me the bottom length of this triangle is 6. I actually need to do 14 minus 6, and what would you get? 8. So the other base is length 8.
So this would be.
It actually is a square, but the last one was a rectangle, so you can't just base it off looks. 1/2 of 8 is 4. What is 8 plus 14? It's 4 times 22.
88.
So it's 88 feet squared. Okay, are there any questions on these? Again, it takes a little extra work, but it shows a little more geniusness if you were to actually do the rectangle area plus the triangle area. That would show you understood a little more than someone who's just always plugging in a formula. Okay, flip to the back. Again, the hardest part for the rhombuses and kites is remembering the formula. I might potentially, I think I'm going to write this formula on the board, but you would have to know when to use it. What do you think the D stands for in the formula? Diameters with circle. Look at where it's drawn inside our shapes.
Direction.
Look at where it's drawn. There's a name for that. It starts with a D.
Don't say it.
It starts with a D.
Okay, well, give me the second. What did we say?
Oh, I know.
That's what I said.
It's what? It's not direction. I heard it, but I don't know who said it. No.
That's a
That's
denominator.
a fat nigga.
That denominator.
The denominator is D.
What is this? What start with it?
Diameters with circles.
Yeah.
And Grant guessed that a long time ago.
Yeah.
I mean, there's a lot of words I can think of, but
Wait, give me the third button.
I don't know any of that was.
How about I just tell you this?
No.
Tell us.
So,
My hint.
No, I got you.
My hint.
Got you.
You want the hint?
Yes.
No, that's cheating.
My hint, which has nothing to do with math, would be word search.
Diagonal.
Oh. I said that.
Someone said it, but I didn't think it was you. Okay.
Okay.
I don't know.
Then I say diagonal. Then I say diagonal. You heard me say diagonal.
You heard a lot of things. Okay. A good question would be, because I said there's potential for me to put this formula on the board, although you really don't deserve it and that you need to know it in life. But I feel sorry for you in that you have a quiz on Friday. So for the quiz for Friday, I will probably write that on the board. But Trey has to know when to use it, which means Trey has to know when he's been given a rhombus or a kite. And let's face it, especially with that one, it looks like a parallelogram. So how are we going to know this is a rhombus or a kite and not a parallelogram? And the answer is kind of obvious in that, well, a lot of us, we spent a whole time in chapter 4 with that yellow sheet of like figuring out the difference between quadrilaterals. I'll give you that. But it's a little more obvious than that. If they're giving you numbers on the diagonal, it's probably a rhombus or a kite, and you need the diagonal formula. It's going to be that obvious. You're not slow at all. So if they're giving you numbers on the diagonal, you probably need the formula that involves diagonals. So seriously, you coming up with diagonal is the hardest part of these. So the area is 1/2 one diagonal times another. So in this case, it's going to be 1/2 7 times 12. What is 7 times 12? Okay, and then half of 84. So it's 42 feet squared. Again, the hardest thing is going to be, can you remember when to use the formula? And if they're labeling that diagonals, you need to use this formula. Okay, and then for the rhombus, again, the same formula. We need to know the length of the diagonals. Why can I not plug in 7 and 9 and say half of...
Because they're not equal to half the diagonal.
Oh, it's only half the diagonal. Notice 9 is only 1/2, so we actually need to plug in what number? 18. 9 plus 9, which is 18. Okay, 7 is only half the number. What do we need to actually plug in? 14. 7 plus 7, which is 14. Okay, what is 18 times 14? What? 252. So a half of 252, 126. So the answer is 126 inches squared. Okay, so let's face it. The trapezoids and the rhombuses and kites were way easier than the parallelograms and the triangles, which seems counterintuitive because those look like more complicated shapes. It seems like the more complicated the shape, the less work they actually require of us. Whereas with the darn triangle, because it's so easy, they have to step it up a notch. What you need to do now is work on many of the things.